Blowing bubbles is an enchanting activity that we often link to the formation of droplets or bubbles in liquids. It's fascinating to discover how bubbles and droplets influence our environment in the most unexpected ways, ranging from the mesmerizing dance of water droplets on leaves to the soothing sounds of running water and even the delightful taste of our favorite drinks. Take a moment to observe the droplets on leaves. Isn't it amazing? Understanding why bubbles form and ignoring the effect of gravity. The shapes of bubbles or water droplets are almost spherical, but why? Notice how these droplets curve inwards, almost as if they are pulling themselves together. This is because the water molecules on the surface behaves like a stretched membrane. Water seems to act as though it's draped in an elastic skin, a phenomena known as surface tension, one of the most intriguing forces in nature. Its tendency to occupy the minimum surface area. The secret behind surface tension lies in the unique shape of the water molecule. The bonds that draw water molecules to each other are incredibly strong, creating this wondrous effect. In terms of surface energy, we can also say that the molecules at the surface stores more energy than the inside molecules of liquid. By any means, if we can increase the surface area, the energy will also be increased. But the natural tendency of any droplet is to minimize the surface energy level. So it's spherical. The bubble eventually pops because the water between the layers of soap evaporates and easily breaks the surface tension. The second reason for the formation of bubbles is the water or air, which means that the fluid pressure acting inside this is greater than the outside pressure. Here, air bubbles are pockets of gas that are trapped within the liquids. Animals that spend a lot of time underwater have evolved some incredibly ingenious ways of exploiting the fact that bubbles reduce the density of water. Now, add some soap solution in water, blow the soap bubble and observe it. Let me start with a simple question. Why can't we make bubbles with pure water? Why do you need soap? If you make bubbles in clean water, they rise to the surface and make a spherical lid like this for a very short period of time, but the surface tension of water is so strong that it pulls this film, breaks it up into lots of tiny droplets. When you blow air into soapy solution, the air gets trapped inside and forms a bubble. In case of soap bubble, thin layer of water connect with air on both sides. This thin film can exist for so long because the soap molecule have reduced the surface tension of water. Now we are going to interrelate this difference in pressure with surface tension. To minimize the surface area, water droplets exert inert force, so the molecular density gets increased, hence the inside pressure is increased. And the same phenomena will be observed in air bubble inside water. Water molecules pushes the bubble to compress, hence the inside pressure is higher than the outside pressure. In case of soap bubble, both the surfaces have the tendency to contract the surface area, exerting forces to inside of air molecule. As a result, inside pressure will be increased. Let the radius of the droplet be R. Inside pressure, which is the pressure of the liquid, will be P1. Outside pressure, which will be the pressure of the air, will be P0, and the surface energy will be E1. Surface energy per unit area is equal to the surface tension for liquid-air interface, which will be considered as S1. Adding very small amount of water in this tiny droplet to increase the volume a very small amount. Radius will also be increased, R plus dr, as well as pressure is decreased. The increment in surface energy is equal to E2 minus E1. Since inside pressure is high, there is a net outward force is activated. Due to this net force, molecular displacement of each is equal to dr. Due to this, work done and energy is increased. The pressure difference is same for air bubble in water also, but in case of soap bubble, because of its two surfaces, the pressure difference is equal to 4s by r. Why do soap bubbles appear colorful? Apart from the spherical shape of a soap bubble, there is another fascinating aspect, the vibrant colors on its surface. These colors are due to the thin film interference. Let's understand how thin film interference leads to such vibrant colors. Before that, let's break down the phrase thin film interference. The film is so thin, it's only a few hundredths of a diameter of a human hair, that is 10 to the power minus 9 to 10 to the power minus 6 meter. That means a soap film is around the same thickness as a single wavelength of visible light, and the interference occurs when two waves meet or overlap while traveling along the same medium. Let's zoom into this. A soap bubble has a very thin film of water sandwiched between the two layers of soap. When light hits the bubble, some light waves reflect off to the outer surface of the film, while others pass through and reflect off to the inner surface. These two waves travel different amounts of distances. The light wave reflected from the bottom surface travels this much extra path, so there is a path difference between these two waves. These reflected light waves overlap and interfere with each other. Our eyes can experience the interference phenomena. Depending on the thickness of the film and the wavelength of light, this interference creates patterns of bright or constructive and dark or destructive colors. So, different wavelengths of light are interfering constructively or destructively at different parts of the bubble, and that's why we see different colors in different areas of the bubble. Effect of temperature on soap bubbles. When the temperature increases, the size of soap bubbles will also increase. This is because the rise in the temperature decreases the surface tension of the liquid. Lower the surface tension allows the bubble to expand more, resulting in a larger and more stable soap bubble. Furthermore, the addition of substances like sugar and glycerine can help achieve even bigger soap bubbles. These additives strengthen the soap film, making it more durable and capable of holding a larger volume of air. Enjoy your bubble making adventure. Thanks for watching.